Good morning, everyone. Myself, Dr. Sreenivas Padala. I'm currently assistant professor in the Department of Civil Engineering from Rama University of Applied Sciences from India. Before I start my presentation, I would like to thank BIM Coordinators Summit team for providing me opportunity to share my findings. The title of my presentation is BIM Integrated Optimization Workflow for Improving Building Performance. So in this presentation, I'm going to present how BIM platform can be utilized to optimize the building volumes instead of 2D spaces for improving the building performance. So we all know that there is a surge in urban land demand, which shifted construction of all the buildings from horizontal to vertical development, impacting the quality of building environments. And the sustainable construction necessitates optimizing both 2D as well as 3D spaces. So volumetric space optimization provides better benefits like enhanced space usage, reduced energy consumption, better comfort, easier construction, and increased rental value. And also, designers can also benefit from creating cost-effective designs by finalizing the layouts based on the volumetric analysis. So by prioritizing volumetric space optimization and integrating multiple factors early in a design, so this BIM-based approach can minimize the need for lateral changes in the project. So we all know that any changes happens, especially design changes, which can occur in later stages of the project. It can have a very costly impact to the project. So in this study, the focus was on optimizing the volumes, building volumes instead of 2D layouts, so that we can have better performance. So when I say volumetric analysis, so you can see in this particular slide, if you take any elevation or any plan, you can divide into various grids like this, like I shown. So in each grid, you can optimize the volumes. Means you can have multiple volumes, like I shown here in the left hand side. You can have ES, EI, GH, the different options of volumes. So instead of playing with the layouts, in this study, we have optimized the volumes basically. That's mainly the volumetric analysis. This is the overall methodology of this study. Initially, a 2D layout was planned, designed, then a 3D model was developed on Revit model. Then using Dynamo plugin, we have extracted the volumes again. So once we got all the volume data from the 3D models, so I have applied a algorithm called non-sorting genetic algorithm. It's a multi-object optimization algorithm, mainly which help us to optimize building volumes with respect to the multiple criteria. That's the best part. So that's what volumetric analysis in my study. So when I say multiple factors, I have considered the space utilization. I have considered the thermal analysis like human comfort. I also tried to maximize the rental value and minimize the construction cost. So utilizing these four factors, I have optimized the building volumes. So once the optimization is carried out, so those data again extracted and again using those 3D volumes, the optimized 3D volumes are developed. From that again we have developed the revised 3D volume. So I will be showing with explaining this methodology with help of one case study so that you will have a better idea. So I use many softwares which all comes under BIM platform. Like I have used Revit, SketchUp, Dynamo plugin, Autodesk Insight, Microsoft Project. Then I also use MATLAB. So they all integrated in such a way that we don't lose any information basically. So these are the four factors I considered. Space utilization, like I said, mainly talk all about utilizing the maximum space in the layouts. Then human comfort. Then cost factors also, like execution cost, construction cost, basically. Then also real estate value, rental value of the building. So the first thing is space utilization. So you can see that various parameters are considered. Area, volume, mainly the volume is a novel thing here. Then type of spaces also, because this concept is applicable mainly for mixed use buildings. We will have different spaces. Each space will have different requirements. So I also consider the XYZ coordinates, and also I consider populations also for each floor. That will be act as an input basically. The output will be the maximum space utilization. So you can see the difference. On left hand side we have before optimization. On right hand side we have a after optimization data. You can see that the occupancy, the people, the population of people occupied in the building is actually more on the after optimization. This is again a mathematical equation. So I don't want to go too deep in this equation, but if you have any doubts, you can also always contact me in the future. Then similarly, this is for human comfort. I have taken internal temperature, volume, type of space, again, temperature variations, air changes, ventilation, everything as input data to optimize the thermal values. So This is how the output will look like. You can see the difference before automation, after automation. There is an improvement in the human comfort in terms of temperature changes will be not different. Too much difference will not be there. It's a more better comfort will be there. Again, similarly, this also we have a I have developed an equation for determine the human comfort. Third is concession cost. So the concession cost I have taken again volume. So volume will be the same parameter for all the optimization equations. Then I have taken even the materials, quantities, concession cost, schedule of rates as input data. So overall aim is here to try to minimize the concession cost when you're optimizing the building volumes. Similarly, this is also again our equation for calculating concession cost. So basically, this case study, whatever case study I'm going to present is applicable in India, in the construction industry. So these rates, everything, the concession rates, materials rates, everything is taken from Indian database. And finally, I also taken the rental cost or rental value. So here also floor area, volume, rental cost per square feet, percentage of rate increase, everything is taken as input data. But here also floor area ratio also another important parameter is taken as input here. So without compromising the floor area ratio, we try to enhance the rental value there. So you can again you can see before automation, after automation, there is the what I can say is number of floors can be increased for same volume. So that's how you can increase the rental space. Then finally, this is again equation for the rental value also. This is a case I have taken. It's a proposed school of architecture building. It has a total area of 8,407 square feet. Basically, it is proposed in India. So these are the plans which I have taken up for the new project. Now these are the volumes. Just one sample I'm showing. So you can see how the volumes are modeled here. So instead of modeling directly the 2D spaces, I have modeled in the Revit the volumes basically. You can see that the level of detail is very high also. These are the several other elevations of the case study. So you can see the level of detail is very deep. You can easily extract the volumes from the buildings. The main aim is of this Revit modeling is to extract the volumes data. So this is an example. For example, if you have a Revit model like this is a 3D model. So we can separate. Finally, I need to take out these volumes out, extract the volumes out, so that I can rearrange the volumes such a way that I can meet all those four factors like space, thermal comfort, concession cost, and rental value. So to do this, what is the process? I use a Revit again to develop 3D model. But here I use Dynamo plugin, which is linked with the Revit file. So I use Dynamo scripts to extract the volumes from the Revit model. So what I get from that Dynamo script is I can extract the number of rooms, number of spaces. I can extract the room numbers. I can also extract the area of spaces. I can also extract the volume of spaces. This is a Dynamo script. So I have mentioned a trial form, and so we have worked with the different trials to get the accurate volume data. So this is just a sample script. So like I said, again, extracting volumes is the one challenging, but later reorganizing the volumes, it requires some mathematical equations, a mathematical process for that. So this is a process. This is the steps for implementing the algorithm. So I use non-sorting genetic algorithm. It is called NSG in short form. There is a version called 2. This again a detailed process. Basically, here what happens, I have considered after all the optimization for, equation which I explained you earlier. I have taken all the constraints also. So I will also use the building data, Revit model data. And finally, all these equations basically coded in a MATLAB here. So what I'm showing to you now is the changes basically. So what you see on the left hand side is before automation, or right hand side what you see is the after automation. You can change the difference between these two plans. But again, you cannot understand the difference between these two plans in 2D layout. So I can show you the elevation. This is the elevation point. So you can see I highlighted few parts. On the left hand side, you can see the volumes enhancement is there. I mean the impact. What is that? You can see there are changes in elevations, which means the space utilization is more in this right hand side model, which is after optimization model. Similarly, you can see the changes between the before automation, after automation model. So what is the end result? So if you optimizing the building volumes instead of 2D layouts, I have found that there is increase of space utilization by 30%. So the number of people who can occupy this building, it is increased by 30%. Similarly, the human comfort also increased by 20%. You can see on the left hand side, like before automation, there are temperature changes are there. Every floor there are different temperatures, but after automation, especially optimizing the volumes, we have found out the temperature changes will not be there throughout the floors. So an entire building will have a same temperature, which means there will be constant variations within the human comfort zone. But one contradictory finding what I have found is construction cost is not decreasing, because when you go with volume changes, every floor will not have the same height. So that again increases the construction cost, but the increase in construction cost is slightly. It is around only 10% only. But this is further compensated by rental value. So we have enhanced rental value by 33%. So even I subtract that 10% increase in cost, net rental value can be 23%. So which is again, so what I'm trying to show here is the rental values with respect to the floor wise, it is also increased. So to conclude my presentation, so the current research introduces a BIM-based framework that enables early volumetric analysis of building so that we can minimize all design changes in the later stages of the project. So BIM empowers the project teams to assess the accurate design data early on, allowing multiple object application for generating optimized building models before construction drawing release. So this integrated framework prevents costly design changes during construction. So opting for volume optimization over traditional 2D spaces offers multiple advantages for all the project stakeholders, such as increased space usage, enhanced thermal comfort, economical consideration construction, then also can also have a more or better style value. So with this, I would like to conclude my presentations. So again, I would like to thank BIM Coordinator Summit for providing me opportunity again for presenting my this one of the research findings of the BIM. So I know this presentation is very short. We will not follow all the slides. So if you have any doubts further, if you want more details on particular any slide, I can provide you. So this is my contact. You can contact me through this any of my email IDs. So again, once again, I thank the coordinate teams for allowing for me to present my findings. Thank you.